Good morning, ma'am. We are the Group 6 and we will present or report the Activity 6 or the Avogadro's constant. Avogadro's number or Avogadro's constant is the number of particles found in 1 mole of a substance. It is the number of atoms in exactly 12 grams of carbon-12. This is experimentally determined value is approximately 6.0221 times 10 raised to the power of 23 particles per mole. Amadeo Avogadro. Avogadro's number is named in honor of the Italian scientist Amadeo Avogadro. Avogadro's number is used to calculate the value of the number of atoms, molecules, etc. in a gram of mole of any chemical substance. Here, Sean Kalim for the next slide of reports.
Good morning, everyone. So for our objectives for today's report, number 1 is to define and use the Avogadro's constant. Number 2, to use Avogadro's constant in converting atoms to moles. Number 3, to use Avogadro's constant in converting atoms to grams. So the materials that will be used in the calculation is our pencil, the paper, our calculator, and our periodic table. For our general formula is number of atoms multiplied to moles of an element over mole of Avogadro's number of an element, where it is equal to 6.0221 times 10 raised to the power of 23. So is equal to moles of an element. So now I will give the virtual floor to the next reporter.
Number 1 given, 3.50 times 2 to the power of 17 atoms of astatine. Solution is 3.50 times 10 to the power of 17 atoms of astatine multiplied to 1 mole of astatine over Avogadro's number 6.0221 times 10 to the power of 2380 atoms equals 5.87 times 10 to the power of 17 moles of astatine. Number 2 given is 4,500 atoms of radium. Solution, 4,500 atoms of radium multiplied to 1 mole of radium over Avogadro's number 6.0221 times 10 to the power of 23 radium atoms equals 7.47 times 10 to the power of 17 moles of radium.
For the given of number 3, 2.75 atoms of silver, it is multiplied to the 1 mole of silver over the Avogadro's number 6.0221 times 10 to the power of 23 silver atoms. And it is equals to 4.57 times 10 to the power of negative 24 moles of silver. Next is number 4. The given is 500 atoms of silicon. It is multiplied by 1 mole of silicon over the Avogadro's number 6.0221 times 10 to the power of 23 silicon atoms, and it is equals to 8.30 times 10 to the power of negative 22 moles of silicon.
May next pa ba?
Wala na.
Wait lang po, ma'am.
Okay.
Ako na lang po, ma'am. For our number 5, 6.23 atoms of Mn. 6.23 atoms of Mn times 1 mole of Mn over 6.0221 times 10 to the power of 23 Mn atoms is equal to 1.03 times 10 raised to the power of negative 23 moles of Mn. For the next number, convert the number of atoms to the number in grams. Show your solution. For our one, we have the given of 3.9 times 10 raised to the power of negative 5 atoms of Ba. 3.9 times 10 to the power of 17 atoms of Ba times 1 mole of Ba over 6.0221 times 10 to the power of 23 Ba atoms multiplied to the molar mass of our Ba, the 137 grams of Ba over 1 mole of Ba. It is equal to 8.87 times 10 to the power of negative 27 moles of Ba.
Okay, for the number 2, the given is 8.02 atoms of zirconium for the solution. 8.02 atoms of zirconium times 1 mole of zirconium over 6.0221 times 10 raised to the power of 23 zirconium atoms times 91 grams of zirconium over 1 mole of zirconium. The answer is 1.21 times 10 raised to negative 21 moles of zirconium. For number 3, the given is 10.7 atoms of tungsten. The solution is 10.7 atoms of tungsten times 1 mole of tungsten over 6.0221 times 10 raised to the power of 23 tungsten atoms times 184 grams of tungsten over 1 mole of tungsten. The answer to this is 3.27 times 10 raised to the negative 21 moles of tungsten.
The given number of number 4 is 2.56 atoms of mercury. 2.56 atoms of mercury times 1 mole of mercury over 6.0221 times 10 raised to the power of 23 mercury atoms times 201 grams of mercury over 1 mole of mercury. The answer is 8.54 times 10 raised to the power of negative 22 moles of mercury. The given number of number 5 is 9.0 atoms of calcium. 9.0 atoms of calcium times 1 mole of calcium over 6.0221 times 10 raised to the power of calcium atoms times 40 grams of calcium over 1 mole of calcium. The answer is 5.98 times 10 raised to the power of negative 22 moles of calcium. That's all po, ma'am. Thank you.
Okay, that's it. Kindly return sa first slide. First slide muna. Sino hindi naka-report? Okay.
Si Salinas po, ma'am.
Let's check. Let's check your answers. So this is Avogadro's constant class, and Avogadro's is used to determine the number of particles, or that is referring to the number of atoms. So according to Avogadro's numbers, ang isang mole ng element or ng substance is equivalent to 6.0221 times 10 raised to the power of 23 atoms or particles. So if you want to know the number of
atoms in a given moles of substance or the number of moles, vice versa, pwede natin siyang gawin. So just like for the first part, i-convert natin yung number of atoms sa number of moles by simply using the conversion factor na again ang isang mole ng substance is equivalent to 6.0221 times 10 raised to the power of 23 atoms. So let's check the answers of the reporters. And I hope also yung mga non-reporters also got the correct answer here. So the given is 3.50 times 10 raised to the power of 17 atoms of our astatine. Let's check if how many moles will that be. So 3.50 times 10 raised to the power of 17 times 1 divided by the number of atoms. So let's this one, cancel this. So again, divided by 6.0221 times 10 raised to the power of 23 is, anong nangyari dito? Kindly check. 3.50 times 10 raised to the power of 17 divided by 6.0221 times 10 raised to the power of 23. 5.87 ito, answer nyo? 5.81. Kindly check. This should be 5.
Ay, 5.81 po pala. Sorry po.
Okay, sige. So please check. This is 5.81 times 10 raised to the power of what? That should be the answer here. Raised to the power of, this should be negative 7. So please take note of that. Again, 5.81 times 10 raised to the power of negative 7 moles of astatine, yung equivalent sa 3.50 times 10 raised to the power of 17 atoms. Okay, please take note of that, of the correction. That's for number 1. And then, for number 2, we have the given 4,500 atoms of radon. Sorry, this one is radium. Divided by 6.0221 times 10 raised to the power of 23. The correct answer is 7.47. What should be the answer here? Ano dapat ito? Tama yung 7.
Negative 21 po pala.
Okay, this should be negative 21. Okay, take note of the correction ha. Cancel the atoms here. Okay, 4,500 atoms is equivalent to 7.47 times 10 raised to the power of negative 21. Okay, again, take note of that. Next. Next, ito mas maliit kasi 2.75 atoms lang. So 2.75 atoms of silver divided by 6.0221 times 10 raised to the power of 23. Let's cancel this. Maiiwan yung moles ha. The correct answer is 4.57 times 10 raised to the power of negative 24. Okay, so this one is correct. Next. 500 atoms of silicon. The same way of solving. Divide natin sa 6.0221 times 10 raised to the power of 23. This is 8.30 times 10 raised to the power of negative 22. So this one is also correct. And then lastly, let's have the number 5. Okay, so 6.23 atoms of manganese divided by 6.0221 times 10 raised to the power of 23. Cancel this. Okay, the answer is 1.03 times 10 raised to the power of 23. So this one is also correct. Any question for this? May gusto bang i-clarify? But do not forget ha, ang isang mole of the substance is equivalent to 6.0221 times 10 raised to the power of 23 atoms or particles para sa conversion. Now, ito namang set of given na ito is asking you to convert the number of atoms not just to moles but sa grams talaga. So yung pattern dyan, aside from having this conversion factor na number of moles to number of atoms, you also need sa last part the molar mass of the substance to, or not really the molar mass, but the atomic weight of the element to convert it further to grams. Okay? Sige, let's check. 3.9 times 10. Ay, ano ba talaga ang totoo dito? Negative 5 or 17? Kindly check. Paki-check ano dapat dyan ang given. Ano yung visit ko ko?
Ma'am, sorry na typo talaga, ma'am. Negative 5 po. Negative 5 po, ma'am.
15 lagi ilagay send. Then let me open the activity. Activity 6. Mm-hmm. 15 dapat 15. 15 dapat ito. And this should be positive, right? Walang negative dapat dito. Okay. So this should be 1 here. 15 ito ha. Okay, so let's check. 3.9 times 10 raised to the power of 17 times 1 mole of barium. Barium is 137. Check. Barium. Okay, that is 1.37 times, this is times 137. Take note, you have to cancel the units, atoms, atoms, moles, and moles. So you will be left here with grams. Okay? So times 137 divided by sa baba, you only have 6.0221 times 10 raised to the power of 23. The correct answer is 8.87 times 10. Okay, let us recheck this. This should be 8.87 times 10 raised to the power of negative 5. Take note that our unit is not in moles. Remember, we are looking here for the number of grams. So again, 8.87 times 10 raised to the power of negative 5 grams of barium. So take note of the correct answer for number 1. Okay, next. 8.02 atoms of zirconium, i-convert natin siya into grams. So you cancel the units first, the moles. Again, ang maiiwan na unit is not moles, but grams of zirconium. So 8.02 times 1 times, what is the atomic weight of zirconium? That's 91. So that is 91. 8.02 times 91 divided by, sa baba, we have 6.0221 times 10 raised to the power of 23 is 1.21 times 10 raised to the power of negative 21. This is grams of zirconium. Okay? Questions? Wala? Sige, let's have the number 3. This is 10.7 atoms of tungsten. So the same way sa pag-solve, 10.7, let's check first if what is the atomic weight of our tungsten. This is 184. Rounded up to 184. Okay, very good. 10.7 times 184 divided by 6.0221 times 10 raised to the power of 23. This is, wait lang ha, cancel. So this, again, this should be in grams of tungsten. So this is 3.27 times 10 raised to the power of negative 21. Okay, paki-recheck na lang ang units ninyo. Hindi yan siya moles ha, at grams yan. Yung sa first part, yung ating moles. And then 2.56 grams, atoms of mercury. Okay, grams ulit tayo dito. Times, what is the atomic weight of mercury? Mercury. This is 201. Rounded off to 201. So times 201 divided by 6.0221 times 10 raised to the power of 23 is 8.54 times 10 raised to the power of negative 22. Okay, correct? You just have to correct also your unit. And then lastly, we have 9 atoms of calcium. So 9 times atomic weight of calcium is 40. So 9 times 40 divided by 6.0221 times 10 raised to the power of 23 is 5.98 times 10 raised to the power of negative 22. This is still grams of calcium. Okay, so I think that's it. This one is a very short na activity actually. You just have to be careful with your units and yung ibang given dyan sa problem. So again, if you're just looking for the number of moles, directly multiply the number of atoms to our conversion factor. 1 mole is equivalent to 6.0221 times 10 raised to the power of 23 atoms. But if you're asked to get the number of grams, multiply it also to the atomic weight of the element. Any question for activity number 6? Meron ba? Meron kayong gustong i-ask for activity number 6? Wala? Sure na? How about the reporters? Wala si Miss Salinas. No?